Hello everybody. I am Elodie and I'm in data science. I will to present the practical presentation on the object detection use the YOLO version 5 method. I take care of the practical case of the pop-up. I give the time for Rockefeller because he can introduce the object detection for the cat. Now I use the pop-up image picture. The most important of the object detection for the practical guide for this presentation, I use an image come as assessment for the human brain that you can identify and localize many objects in the photo. And this is the computer vision. Talk about the object detection. One most popular algorithm for to date for real time of YOLO. YOLO means that is the very important for the computer vision method. YOLO is you only look on. For this tutorial, I will present the why I learned to perform an end-to-end object detection project. What is the YOLO? Because what is YOLO? Many people say YOLO is that. YOLO is the most algorithm performant to use the object detection. We have many versions of YOLO. The most recent version is 5. You can share the link of the most recent version to use and the version 5 in this link. The tutorial oriented the background of object detection algorithm. We see that the practical implementation lead. And my Jupyter notebook is available on the KmerAi drive. I put my Jupyter notebook on here. For the presentation, I begin to the data set ready. We to have if my general data set in the pop-up is different image. You want to click on the page, you have the image to have stop or don't click, don't enter for any page. Now I use 2007 image picture or the YOLO version 5 method. We recommend to use many images by class. Or for this class, I don't have many images. I don't have only 215 images. When to use the YOLOs, it's very important to labeling the image. We have many platforms of the labeling image, but in my case, I use the Make Sense AI. The Make Sense AI is the one annotation which we use to annotate the image. Then when to annotate the image, we have represent many form of represent image. Different form, you have object class ID. We have X center, we have Y center, you have both words and both height. For example, when you have one class of my case, my class is a pop-up. We have, for example, 0 for the object class ID. Another class we have X center, we have the X on the number 0.5 or 0. I don't know, Y will have 0.5 anyway. This when we have when we labelize the image, we have the data direction for the why we use the YOLO. It's very important to put the different image and label for the link. We have a data set. My class is pop-up. We have image. In this image, we have train, validate, and test. The same of label, we have train, validate, and test. This is the configuration field. This is the data direction field for the most important when we use the YOLO. Oh. And the configuration field for the YOLO, we have three configuration field. For the training, we have a field of INL field. The train field data configuration field have three customer data set. We have train data set, pop-up, image, and train. We have val for validation and test for testing image. Now I have one class. One class is the pop-up. The name class is the pop-up. If you have if you see the pop-up up north, when you see the pop-up, you observe the probability of the you can see this pop-up of in the image. And the second configuration field is type parameter configuration. It's most important for what when we train your model, we use the YIN configuration field and this directory. The directory is very important because in the YOLO we have a specific directory. We have, for example, for my project we have project YOLO version 5, and you have data pop-up .in. This is the extension of configuration field. We have model on YOLO version 5 S6 YN. The train model, we train your model for the size of YOLO version 5 because it's the small data set I have. I don't have many data sets. We have already we have support several representation architect. We have the parameter size of version 5 small, version 5 medium, version 5 large. But now when I don't have many image, I change to version 5 small. Now I will train my model for the small version 5 YOLO. Now I train my model. The command to put for the train your model is this command. It's very simple. While we put the directory and the data set, we enter this command for the notebook for your notebook, and you enter this command for your notebook. Batch is the batch size. I use batch size that you are run over. Epoch is number of epoch. Data is the path to the data configuration files. CFG, that is the path to the model configuration file. Y is the path of the initial path, and cache is the cache image for faster training. and you have the link of your image. This is link for the hyperparameter 5. When we trace the model, we use the Y of the model training. This is the Y of model training for the train your model. After you train your model, that is the, for example, that is the, when I use my pop-up image, I have the practical case for the pop-up. Is the result of validation, the result of the training model. It is important to understand the metric and loss for the YOLO. You see that this image, the box loss, the object loss, the CLS loss. The box loss is boarding box regression loss. That is the mean square error. That is the mean square error. The object loss and the confidence of object present is the object loss. That is the binary cross A entropy. That is the train loss. For you have one class because it's this pop-up. If you see pop-up or not, we have one class. If you have two class, we have a two train and different code for the train loss. Another metric is the precision recall on MPA. The precision measure how much two box prediction are correct. We have precision equal to true positive false on true positive plus false positive. And the recall is the measure for much of true box were correctly predicted. We have true positive on true positive plus false positive. That is the different measure and all the different results to have the training model. And the MPA is the interaction over union threshold of the 0.5. That is equal to 0.95. Donc, this model is correctly trained. When you train your model, you test your model of the image testing. The image testing we have, in my image testing, we have no more image testing, but we can also obtain the precision recall queue with automatic cell for edge validation. This we use that is you see that pop-up and train of 0.98 and all class is 0.98. That is we see that the validation model precision recall curve of the test data speed. And I test your model with the practical case. In my input, I input the image. You can input the image and video directory and webcam. That is my input. By input, the different pop-up I input for the model. You say any pop-up for the model.
Are we supposed to get the sound? Because I don't hear it.
I don't need the sound. This is from
Okay.
the video. But after we put this test image for on video, we have the your model detect which is the pop-up, which probability is detect for the pop-up or not. This is the video. Now we detect the pop-up on probability of 0.93. Since is that 0.93, this is the pop-up, this is the pop-up, this is the pop-up. Another thing is not pop-up because I don't detect if the pop-up or not. It's not pop-up is there. This is the pop-up, the probability is 0.78. Okay, you can use this method which is enough which in several fields. For example, I take care of the example of the Cameroon. We can use the medical field to detect of anomaly of the different patients. I don't see that it's not very difficult, but and this method is very popular. And my notebook is available of the KmerAi Drive. If you have any question or suggestion, I'm available this by my email address. Do the time contact will answer question in the chat. Thank you for everyone.
Thank you, Luigi, for your
My
presentation.
email address is